Hey everyone, and welcome. Today, we are diving into something that so many of us deal with, taking an older application and making it truly modern. We're going to map out the entire journey from a clunky, self-hosted RabbitMQ setup to a super resilient cloud-native system on AWS. Let's get right into it.
So, let me just ask you this straight up. Is your message broker holding you back? I mean, when was the last time you had to worry about it failing? If you've ever been up late, patching containers, or just stressing about that one single point of failure, you are in exactly the right place.
All right, first things first, let's take a look at a setup that probably looks really familiar to a lot of you. Now, on the surface, it works, right? But underneath, well, that's where the hidden risks are lurking, and we need to pull back the curtain on those.
So your typical event flow probably looks a little something like this. A request comes in, a service does its thing, and then boom, it publishes an event to a RabbitMQ exchange. RabbitMQ then acts like a mail sorter, using a routing key to drop that message into the right queue, where some other service, maybe for shopping or products, is waiting to pick it up. It's a classic, and for a while it gets the job done.
But here is the problem. That RabbitMQ broker, it's just another container running on a server that you have to manage. It's a massive single point of failure. If that machine hiccups, your messages could just vanish. And what about high availability, or scaling, or replication? That's all on you. It is a huge, huge operational headache.
Okay, so we've identified the pain point. Let's talk about the solution. Our first and most direct upgrade on this journey is swapping out that fragile RabbitMQ container for a cloud-native powerhouse, Amazon SQS.
And honestly, the difference becomes crystal clear when you see it side by side like this. Just look at that SQS column. Scaling? Automatic. Durability across multiple availability zones, built right in. Dead letter queues? Native. The best part? Your operational maintenance goes from high, which is a full-time job, to basically none. You just hand all that complexity over to AWS.
And really, that's the core trade-off right there. You stop doing the risky, tedious, nail-biting work of managing a broker yourself, and in return, you get a system that's automatically durable, incredibly scalable, and just fundamentally resilient right out of the box.
And that's exactly what SQS, Simple Queue Service, is all about. It's a fully managed service. Its only job is to handle message queuing, so you never have to think about the servers, the patches, or the scaling. It's a super powerful, direct swap for your old setup.
Now, SQS is a fantastic replacement, no doubt. But what if you want to take it even further? What if you want to build a truly modern event-driven architecture? Well, that's where AWS EventBridge comes into the picture.
See, with EventBridge, the entire flow gets a major upgrade. Your service doesn't publish to a specific queue anymore. Nope, it just sends an event, like, hey, a new customer was created, out to a central event bus. Then EventBridge looks at that event and, this is the magic part, it uses rules to send it to all sorts of different places at once. An SQS queue, a Lambda function, an analytics pipeline, all from one single event.
And this, right here, is the absolute heart of the architectural shift. The service that created the event has zero idea who is listening. You could add 5 new downstream services tomorrow, and you wouldn't have to change a single line of code in the original service. That is what true decoupling is, and it makes your system unbelievably flexible.
Okay, so this all sounds amazing in theory, right? But the million-dollar question is always, how do you get from A to B without a big bang release that breaks absolutely everything? Well, the key is a safe, phased migration. Let's walk through that roadmap.
You do it in 3 simple phases. Phase 1 is go dual. You actually change your service to publish events to both RabbitMQ and your new SQS queue at the same time. This lets you test the new path in production without any risk. Once you've confirmed it's all working perfectly, you hit Phase 2, cut the cord. You just delete the RabbitMQ container and all its code. And that, my friends, brings you to Phase 3, where you're fully cloud native.
So, you've gone through the migration. What's the actual payoff? What does your architecture really look like now? The transformation is pretty incredible.
This slide just captures that shift perfectly. On the left, it's the old way. You're juggling everything inside one host, the database, the cache, the message broker. It's all your problem. But look at the right. All you're focused on is your service. Everything else, the heavy lifting, is handled by powerful, managed AWS services.
And this right here is the result. Your operational burden just completely evaporates. All that time you spent patching, scaling, and just worrying about your broker, it's gone. You get that time back.
This isn't just a technical win, it's a huge win for your business and your team, because now you can focus on what actually matters, building great features.
So, the big question, which one of these should you implement? Well, if it's for a resume project, going with SQS is perfect. It shows you're competent with core cloud services. For a portfolio project, where you really want to show off your skills, go with EventBridge. It demonstrates you understand advanced, modern architecture. And for a real-world enterprise app, you're probably going to end up using both to build a super robust and scalable system.
So here's where we land. By getting rid of the operational weight of a self-hosted broker, you're not just swapping out one technology for another. You're unlocking a whole new level of architectural freedom. You're literally buying back time and focus for your team. So the only real question left is, what will you build with it?